You've selected the latest chip from Analog Device for its unmatched performance and competitive price to integrate it into your new product. For the proof of concept, you would think that starting with an evaluation board or a prototype with a single chip and available code will put you on the right track in less than a month. But soon it will be time to scale the solution by adding some more channels, adjusting all the clocks across components for synchronization, adding the control functions in a processing unit with a network interface and maybe some storage functions. In addition to that, you'll need to manage the power and cooling, keeping in mind that the result will have to be deployable. Before you could start work on adding value with the application software side of your product, it could take you months of time spent on support questions between lots of different suppliers just to validate the hardware. This would postpone product validation and the time when you are finally ready to go to production. Instead, you could start by referring to ADI partners in the ADI engineering zone. You would notice that the latest ADI chips are already embedded into a selection of modules built according to open standards. The same open standards are trusted and chosen by the majority of embedded computing system integrators worldwide. From there, you would already be one step ahead, ready to integrate your solution into a variety of commercial-grade or ruggedized rack-mount enclosures with intelligent management to guarantee the cooling, power safety, and reliability. In addition, all the peripheral modules are there to build your system, such as FPGA, single-board computer cards, I/O boards, switch, and clocking modules. Vadatech can deliver everything from modules to the complete rack-mount solution, including the wrapper between the hardware modules and the ADI standard software tools, making it the best way for integrators to build a deployable solution and get product to market faster. We want to analyze and demodulate a signal in the GSM 900 band. We have connected the GSM antenna to a splitter. Having a Vadatech FMC214 with the AD9361 mounted on a Xilinx FPGA AMC carrier board on one side and a spectrum analyzer on the other. We have determined that our signal of interest has a bandwidth of 10 MHz. Note that the signal of interest is very low power, with an interference signal at 950 MHz. The first step is to tune the AD9361 filter using the Analog Devices Filter Wizard tool. We create a low-pass filter with a passband of 5 MHz and enough attenuation on the stop band to filter out the out-of-band interference. The filter is imported into the Vadatech DAC series software. After the initial configuration of the FMC214, the receive signal from the AD9361 is streamed in real time to the graphical user interface for analysis. Vadatech keeps the complexity of the actual device management away from the user. Everything is simply managed by config files, and just by using open, copy, paste, read, write, close, and all parameters can be changed on the fly. For those who want to poke into lower-level details, the Analog Devices tool provides debug options to access all registers. And Vadatech's DAC series software is provided with the complete source code. DAC series with software wrapper for Radioverse, for the programming of the quad AD9371 and the single AD9371 or AD9375, is available from Vadatech. The MRT523 from Vadatech is a standard module including three AD9653 A to D converters, providing a total of 12 channels sampling at 125 MHz with 16-bit resolution. The ADC module connects to a standard FPGA board via rear transition connector. This module is used across high-energy physics research applications. Vadatech DAC series allows the users to quickly validate the hardware configuration and focus on the application side of their development. In addition, this Vadatech BSP includes a series of blocks to accelerate the development and quicken the time to market. In order to start the acquisition, a user will always need to define a clock source, a trigger source, which type of trigger event will cause acquisition to start, and additional parameters such as the duration of the acquisition. All of this is simplified for the user to adjust the parameters on the fly, allowing the user to quickly implement the acquisition of multi-channel A to D and real-time data transfer to a single board computer. The DMA engine is monitored in real time, providing data throughput information and memory buffer status to confirm correct operation. Optionally, for users who would like to use MathWorks tools such as MATLABs and Simulink to perform data processing in the FPGA, Vadatech DAC series includes a Simulink block for the user to load their IP. The Simulink parameters are automatically linked to the upper layers, and the user can change the Simulink variables directly from the graphical user interface.